Man, I need to get that other screen. Make this a lot easier. All right. Hello, welcome to ClusterDuck Protocol Stream 5. We're here today with Timo, Brian, and Zach. We're going to be doing, so what this stream is we're going to be doing a live coding session where we work on real issues in the CDP and do a pair programming session. So feel free to comment during the stream or even later, see how we can improve, as this will be an ongoing process. So today we will be working on, so you guys are on, so you want to say hi.
Hello, world.
All right, so for today, Timo is going to go over today's task. So Timo, take it away.
Yes, so today we wanted to work on something that we wanted to work on for a long time. It's a PapaDuck queue, and what happens now is when the PapaDuck, which is the gateway to the cloud, isn't connected to MQTT or Wi-Fi, if a message comes in from a mama duck or another duck, it won't actually publish it because there's no connection, and it will disappear. You're never able to retrieve the message; it's just gone. Which is very bad because whenever your MQTT disconnects or your Wi-Fi, the messages that will come in are just, they disappear. So what we are going to do this stream is we're going to build a queue, and this queue will store the messages that come into the PapaDuck when there is no connectivity to the MQTT or Wi-Fi. We have different backhauls. We're working the LTE, the Iridium satellite network. For all of these, it's the same problem. If some of them drop out for a minute, all the messages will disappear. So in this stream, we're going to build a queue, and the message that comes in will be tried to be published. If it did not publish, so there's no connectivity, it will be stored. There are a couple things you have to figure out. How many messages do we actually store in this queue? Like if hundreds of messages come in, you probably can imagine we won't be able to store hundreds of them at a time. So I think for this stream, we'll keep it simple and just try to build a simple implementation. The next thing is we need to figure out, where do we implement this in the code? So how it works is whenever a message comes in on the LoRa radio, we send that message as a buffer to our INO file, and in that buffer will be converted to JSON, and that JSON will be published to the cloud. What we're going to do is we're going to try to store that JSON, which is already we're going to store a buffer because it contains some important information, and then we'll try to publish. Nick will tell a little bit more about what kind of queue. There's a C++ way of doing this, and the other thing we need to figure out is the oldest message that came in, we probably need to destroy when we're adding another one on the top. So it's kind of like first in, first out when you're publishing, but it's also first in, first out when you're deleting messages, when you're reaching the limit of amount of messages we're storing in the queue. So we wrote down a quick step-by-step, and I think Nick will go through this while we're coding, but the first thing we do is initialize a queue. So we are telling our program there, hey, we have a queue we want to utilize. Then what we want to do is we say, if the packet did not publish to the cloud, store it somewhere. So put it in a queue. We need to figure out the limit of the queue. And whenever we're back online, we need to take the whole queue and publish it up. So we'll explain a little bit more while we're going, but the essential thing is the PapaDuck, which is the gateway, if it's not connected, it will destroy messages because it won't store them anywhere. We're trying to build a queue where you can store messages to publish when you're back online. So, Nick, please take it away and start coding this masterpiece.
So we're gonna jump right into it. So as Timo said, we're going to be putting in a queue. So just basically implementing a buffer for when we're not able to publish messages, because right now when we aren't able to publish a message, the message is lost. And so especially for disaster relief devices, we don't want to be losing that data. So what we're going to do is we're going to go into our PapaDuck INO. So here is our ClusterDuck Protocol library, and in our PapaDuck example, we're going to go grab and do this in the PapaDuck INO. The reason why we're doing this in the INO is because we have a method here called quackJSON. Now, what quackJSON does is it takes one of our LoRa packets and we'll take it and turn it into a JSON document. That JSON document, so in the same method, we are going to be publishing to the MQTT. So MQTT is our connection to our cloud database. So we will be publishing our data to whatever topic that came in for the packet, and then we're going to go through right here is where we try to publish to MQTT. So when that fails, right here we don't do anything, and it moves on, and this packet ends up getting completely cleared. So this is where we're going to be focusing and adding our queue. So what we should do first, so there is in C++, there is a queue. So if we do include, let's see, queue, here we go. So I think that's how it is implemented. So this is what we're looking at right here. So the STD queue. So yeah, so we have it here. All right, so that looks good. All right, so now we have our queue. Now we need to create one. So when we create our queue, we need to tell it what kind of object. So we had the option here, so we could have used the CDP packet right here. So this is a packet object or a struct that we have that makes it really easy for us to put all this data into the JSON document. We could have used this CDP packet, but we're not, because the CDP packet doesn't contain the topic. And also on top of it, by using just the buffer, we can just reuse this quackJSON and not have to create a whole nother method just for trying to publish messages again. So, which we kind of are, but we don't want to do too much double work. But we might change that approach as we go on. So first we need to initialize our queue. So I think where we can put this, where feels like a good place. So maybe put it after this timer. So AT, let's see, queue. All right, and the type of queue is going to be this SC vector byte. So that's the type. All right, here. And we're going to call that, what should we call that? What would be a good name?
That's a good one.
Can't call it packet buffer. We already got that.
Build packet buffer?
Build,
or packet queue, could that be just a general name?
So we'll just call it packet queue. All right. So the next order of business is to, when we are failing to publish, we want to let's see. So that would be packet queue dot, let's see, push, and we're going to put packet buffer in here. So this will add the packet to the queue. Seems simple enough. Now, all right, so that seems all right. All right, so that's a good start. So we only really need to put it in here because we have a callback function. So on receive, so if I go to setup, we go to setup here, on receive duck data, so whenever a packet is received, it will do the handle duck data. And in handle duck data will bring us right back to quack JSON, and quack JSON will bring us right back to here, the packet queue.
So even when Wi-Fi is disconnected, we will still try to publish.
Earlier we had removed blocking. I think there might actually be a better way for the MQTT. We can actually look. They have a non-blocking. Even though this one is how we have it, it's not really blocking, but I think there's a non-blocking method for connecting to MQTT that might actually be better than what we're doing. So we might want to explore that. Let's see, where is it? It's Wi-Fi. Set up MQTT. There might be, actually we should look and see. There might be a better way to do it than we are doing it right now. But yes, even while we are trying to connect to Wi-Fi or MQTT, we should still be able to receive packets. So actually what we can do here is .print, so just for us to see. Now what we can do is packet queue dot size. Let's see. All right, so this way we'll print out. Oh, here.
Will it print out the amount of packets in the queue?
Yeah, it'll print out the size.
Okay, that's perfect. And with that size, we can also say we can do like if size length or if size is bigger than 5, do this or do that. For this example.
So we save this here. Now we can go into Arduino when it decides to open. So here we've opened examples. If you need any help figuring out how to get set up with our ClusterDuck protocol, check our GitHub, and in our wiki we have very detailed instructions on how to get set up with Arduino IDE. So since we are just testing the queue, we do not need to set up any information here because we are anyways trying to not connect. So let's see, we should see our queue right here. So So let's see. Let's just do a compile. So let's just let that run. Make sure we didn't make any mistakes. I should also plug in this little guy. So I have right here, I have a little Heltec device that we like to use for prototyping. They're really easy to get. You can get them on Amazon, or you can order them in bulk from any manufacturer. So these guys are not too expensive and pretty easy to work with. All right. So that guy's
You need to know how the whole structure works with MamaDucks, PapaDucks, and ducklings. That's all explained in a wiki, which we'll link below.
Mm-hmm. Okay, so once we've got this sorted, now we're going to have to figure out now when we are connected to start publishing those packets. So if we do that, so we would want to do that here. So if we look, Wi-Fi connected, so I think for now what we'll do is so we're going to want to put it here. And we're going to want to also put it here.
Perfect. So that will empty the queue whenever the connection is back online.
Mm-hmm. All right, so we are still compiling. So maybe we can start adding to here. So if packet queue size is greater than 0, so do something. We're going to do this same thing here. All right, so what we're going to need to do is we're going to need to put another function.
What are you trying to do?
I'm going to put this on the bottom. So what we're going to need now is a method to, if there are messages in the queue, we want to start publishing them once we're connected to MQTT.
So we need to push them into Quack JSON?
Yes.
Okay. How are we going to call this method? Retry something? Or...
Let's see, I would say publish queue.
That sounds good to me.
Publish queue. I don't know. So publish queue, and what this is going to be is for I equals 0, I is, so size is, let's see, so less than equal, like normally. Less than packet q dot size. What am I doing wrong here?
Perfect.
There we go. Let's see, is this compiling yet? All right, it's done compiling. Okay, cool. So why don't we do a little test? So, let's see, com8. Let's see what's in here. Is this the board I just connected? Nope. That is something else. 14, let's see. Okay, there we go. That's from some testing earlier. So let's upload. So I have a duck right now that is sending messages every couple of seconds. So we'll be able to see those messages while it's trying to connect to Wi-Fi, which should put the messages into our queue. And then we should be printing out the size of the queue every single time we we increase it.
You might want to do like a format so we know it's the same format as a logger, but we can do that all later.
Yeah. So that's all stuff that we will be putting in later.
Yeah.
We'll update that, but for right now, we're just gonna be just focusing on functionality, and then we'll go back and add better documentation. All right, so let's see. Done uploading. So let's check the serial monitor. If it wants to open here. All right, cool. So if I turn off auto scroll right here, so you can see that the publish failed and our queue is increasing. So it's working. So that's a good thing to see. But not connecting to MQTT is not nice. So, all right, so it keeps adding. 254.
So you have duck streaming, right? You have a duck streaming in your bedroom just continuously, or
yes, continuously.
Yeah. Oh, perfect.
Yeah. So you can see here, it's all it's doing is a counter. So even though we are trying to connect to Wi-Fi and MQTT, we are not. We are just keep on adding to the queue. Now there is a little bit of an issue where if we continue to add to the queue infinitely, we will eventually run out of space. So we're gonna have to fix that later. But so at least we can show that it is working.
The way we can handle it is we can say if the size of the queue exceeds 50 or 30, whatever we choose, so we can calculate how much we can store. We have to delete the one that got in first, and that shouldn't be a very difficult thing. But,
well, yeah, we can just pop it. So
yeah, correct.
So what we want to do here is we want to. So what we're going to do
So actually, got a comment in our chat. It says in published queue, I think it would be better to have a while loop to empty the queue while packet queue is not empty. Do
Yeah.
this.
Yeah, so that's
Um,
actually, I was thinking about that too, that a while loop, if I should do a for loop or a while loop, but
because he says that the size of the queue changes when pop is called, and that makes
mhm,
sense.
yeah.
Um,
So yeah, so why don't we do while, let's see, while packet queue,
dot
yes.
empty.
Oh yeah, I got it empty, that's right. So it's, let's see, packet queue empty.
Yeah, so it's a not, so you have to do while not empty.
Yeah.
But just at the
So let's see. I'm just wondering if I guess we can just return. Yeah, so okay, so what we so why don't we start with this then? So we will take, so we just want to peek at the first one. So what we want to do is quack JSON, and we're going to do packet queue, and I think it's front. So we just want to look at the first one because we don't want to pop it just yet, because it could be that even though we are connected to MQTT, it could be that we are still failing to publish. So we don't want to pop it just yet. But now the one thing we have to figure out is how do you find out if this has failed. Now, what we probably should do is, actually this would be a good opportunity to have quack.json actually return return error code. So here, if it was successful, return 0. Return -1. So now what we can get the status. Did it Well, I guess we could just pop it, right? Because then they'll just put the message back at the end. Because then we wouldn't need the returns. And then what we would just do here is we would just pop it.
could work.
Well, yeah, but I don't know if that's the right thing. Let's see. Let's pop, yeah. Is it not? Oh, because this is, wait, what? No suitable constructor exists for void. It's G vector byte.
Like if you go to the stream, you can Rory Alston's common thing. We can do quack JSON packet queue dot front, and then we can do packet queue dot pop.
Yeah, so that's what I was doing before. So that's what I originally thought. And then afterwards, like once that's successful, because we want though to see, so because like if we did front, we want to confirm, right, that that Quack JSON was successfully published, right, before we pop. Because if we pop and it failed, then so equals -1.
He says that, which is a good comment, pop doesn't return anything. You have to first call
okay.
front.
Okay, so it doesn't. I see.
Google is deleting his messages probably because it contains C++ code. So you don't be able to see it, but thanks for the comment.
Thank you.
We haven't actually used the queue option. So we literally just, we did some quick research before. So thank you for the comments.
Yeah. So actually, I haven't used queues before in C++. I'm not familiar with it, but just the general idea. But so okay, so then if n equals 0, then we want to packet queue dot pop. Okay, so this doesn't return anything that would work. Now, if it the problem we have right now here is that when QuackJSON returns a -1, we are adding into the packet buffer, or adding into the packet queue. So what we'll end up having is that we have the same packet buffer in the front and in the back. Would then it make sense to use DQ? And then we have to remove it? That doesn't make sense. Let's see, what's the best way to handle this? Because so else, what do we want to do?
What is the thing you're trying to figure out?
Well, because the problem is we have a situation. So we do the publish queue, right? It runs through, and then we have it fails again. So it failed once, it gets entered into the queue, then it fails a second time when we try to republish it. If we leave it as it is, because I guess we'll just what we should just do is just pop it, so we don't even need these error codes. We will either way pop it, but the only problem is on the database side, the messages will be out of order because so the timestamp is only recorded when it gets to when it's published, not when it's received. So what would happen is then the packets would then be published out of order. So then that way we wouldn't know when the sequence that things were done, which depending on what kind of information you're sending, that may or may not be an issue.
Especially with linking packets like we did in stream 3, we need to have them in order to be able to link them.
So, what would be the best way to do it? Because I kind of don't want to change this from a queue to like a DQ, where we can just then delete from the bottom.
Because you're not able to retrieve the latest one first.
So, so if we just I don't feel it's right if we let the packets come up on the bottom. was, let's see, there's a DQ. Element to the back. Yeah, we can pop the back.
So don't you want to like whatever got into the queue first? You also want to publish first.
Yes, but the issue, yeah, we want we want that first in first out, which we could do with the DQ. But so what would be different if we did DQ instead? So what we'd have here is what, how was it? How is it initialized? Let's see. Okay, so if we go to we do this instead. And let's have here. So it works the same way or similarly. So we want to push front. And then here and here we want to pop front. And then here we would do packet q dot pop back, because we end up with and then what we want to do here is, let's see, return. We want to exit the while loop. Will it return? Because if we end up here where we're not able to publish, because that means it will come back as a quack.json will turn a -1, which means it's not able to publish. We can probably safely understand that the rest of the messages are not going to be able to publish. So we don't want to be stuck in this while loop for forever, because it's not able to publish. It won't even be able to try to reconnect. So we need to exit.
Got it. So we pop it and we try, and if it doesn't work, pop it back.
So if it does work, we're gonna pop the front. If it doesn't work, we need to pop the back, because because when it fails, it'll always add it'll add to the back of the queue.
Got it.
Right.
Okay. So then the order changes the messages.
Yeah, let's see. Push element to the back. Wait, let's see. No, wait, we don't want to push the front. We want to add to the back. Wait, am I doing this wrong? Let's see. So we want to, if we want to put an, oh, okay, so no, we don't want to do push front. We want to do push back. So, okay, so I did that wrong. So when we fail, we want to do push back. Here, not push front. That
does push back mean push it back into place, or push it back?
Push to the back. So okay. So push front means it inserts it into the front, and push back inserts it on the back. So so the DQ is you're able to access both sides, or you're able to insert on either side of the queue.
Perfect. So how do we make sure that the message stays in the correct order? Because if we take it from the front, we want to push it back at the front, right? If it fails.
So when we are publishing, we're trying to publish, we're only peeking at the front.
Got it.
So we're not popping it. So we don't pop it until we get the confirmation that it was published.
Okay.
So that's okay. And here will help us prevent from the size becoming too big.
Okay, perfect.
Let's see. Okay, so I think this is a pretty good spot to... Oh, we need to actually call this.
Try not to, but we're far from home. Perfect. No. Yeah.
All right.
Awesome.
So okay, so we can publish Q here. I think it looks good. Let's just try it out. Timo, could you actually create a test credentials for the Papa so we can try this out?
Yes, for sure.
And then just send it to me in the video call.
Okay. Sure.
And we'll just make this as a temporary one.
It will take me a second to create this,
That's
so
fine.
nobody can see it.
Yeah, I'm just going to just compile anyways. It's going to take a little bit of time.
Okay, I am creating you a MQTT duck.
Oh, actually, you know what? There was actually an even better way to do this. So now that QuackJSON returns a number, what we could have done is we could have done here, it would have been like if, yeah, so we could have just done here. If QuackJSON equals -1, then you would do this part here. And then that way we don't need to do the extra step of popping back because, yeah, so that way we don't have, okay, so this is actually better.
The credentials are in your Meet chat.
So,
are you able to see that without exposing them?
Yeah, no, I can.
Are you able?
Yeah, here.
Cool.
So, okay, and then, all right, so it compiled. So what I think what we might do is go back to what we originally were doing. We do here. I'll actually. So I think we're gonna go back to just a regular queue, and we just do push, and instead of DQ, Q,
So you're going back to normal queue.
Yeah. So the reason for that is that because now that QuackJSON returns a status code, right? We can say when we do handle duck data. So now we can split it up so that it's the queuing is not controlled by Quack.json. It's handled outside of it, so which is much better. So now when Quack.json returns -1, then we put it into the queue, and this is when we receive the packet. So now this won't interfere with when we try to publish. So here we'll just do pop, and then we don't even need this statement right there. Oh, we need this. Yeah, so now we just take out that whole extra step because we don't need to do that, and we don't need to worry about what was happening before.
Perfect.
Right? So let's see. Yeah, so it says 0 if it's -1. What we'll need to do, if it's -1, then we still need to return. Yeah, so it's just a little less complicated because we don't need DQ because we don't. There's nothing
that we need it for, and it also makes a lot of sense because we've experienced with Quack.json. You don't want to add too much. Mm-hmm. We wanted that to be as fast as possible, even though this won't add like any milliseconds. But staying away from tampering with Quack.json is always good.
Yeah,
you gotta
just needlessly complicated, but
the common that you did a good job of doing it this way.
Yeah, so this is better. I'm happier with doing it this way.
Yeah, and somebody said good job in the chat. So
yay! Oh, that's
we know what we're doing here, or at least you know.
Well, that's the whole spirit of coding, right? Is you build things up and tear them down because you can build them better and higher next time. Exactly. So that's the exciting adventure of coding. So that looks much better. We're going to also put in these credentials here. So we got a token. So let's go to the top here and the token. This is a PapaDuck device ID stream duck, and then the org. What's the org number? What's it? 9C.
9C NFO.
9C NFO. 9C NFO.
9C6 NFO.
6. All right. Okay. And let's upload this guy.
You're missing a. Okay, you got. Sorry. The stream is behind, so I didn't know if you had 6 or not.
Oh yeah, I've thought before it was working better. So I don't know. We'll have to figure out how to optimize the stream. At least hopefully, is it easier to see the text on the stream now?
Yeah, that's better. It's actually it makes sense if there's like a 2 seconds delay because we're on a direct phone call, and of course you have to stream to YouTube, and so it's actually fine. Sometimes the screen is behind of what you're saying. So perfect. So now you've added your MQTT credentials, but you did not add your Wi-Fi credentials.
Exactly. So I did not add my Wi-Fi because we want to start populating that queue. Oh, what I did forget is to I would have liked to put in somewhere here we can show that the size is going down. I'll just make it a little bit nicer for us.
When this works, we're definitely going to implement this into all the other Papa examples. I feel like it's very useful to have this.
Yeah, it's simple, and it will it does definitely it doesn't hurt to have. Yeah, well, next after this works, we're going to have to put in something to check the size so that we don't, Because sometimes we have it where the duck is not connected for a long period of time. We need to manage that. The devices do not have that much space. All right, so it's
And every device has a different flash memory. Every packet will be around, I would say, 180 bytes or something. So you have to calculate how much we can store.
All right, so what we can do now is what I'm going to do is we have a really nice feature with the PapaDuck is that you can set up the PapaDuck by connecting to its Wi-Fi access point. So if I connect to it, and then I go.
You know what I just noticed?
What?
We never tell in the serial monitor that there's no active Wi-Fi connection. It only says could not connect to MQTT, but there we should mention as well your duck is not connected to the internet right now, so people know that the Wi-Fi connection is something.
Let's see, why is it not able to reach it? The IP is
192.168.1.1.
Yeah. I need to turn off the. Let's see if I go here. 92.168.1.1/Wi-Fi.
How come the messages that it sends, the DDUID is blank?
That's the destination.
Okay.
And which is it's 0, or it's null, so it's not going anywhere. So that's like for something when we want to send specific commands to a specific duck, you can use that as in the header saying that this command is for this duck. But if it does not have a destination, it goes straight to Papa.
Gotcha.
Why can't I connect to a Papa?
Are you connected to the network?
I am, but I'm having issue. Let's see here. Let me just try opening up a new tab on my phone. 2. Why is it can't be reached? Oh, this one could be one that has problems with. Here, I'm gonna try uploading it to this other one. That one might have. Also, it might be an issue that I have 2 PapaDucks right next to me. So I'm just gonna upload this one more time.
We'll get SSID interference. You have 2 of the exact same ones.
Yeah, I might unplug the other one for a little bit. So I have it right here, just to make sure. But in the meantime, we can start working on limiting the size. So there's only one place where we're adding to the packet queue. So what we're going to do is we're going to put if packet queue size. All right, so is, let's see, greater than, let's say for now 5. Then what we're going to do, well, I don't know, maybe, I don't think there should be a situation where this won't catch it because it's the only time that it's being added. So we should just be able to do packet q dot pop, because then we want to get rid of the one that's on top, and then I want to do this. And then we do here. So this will should limit it to 5. Let's see here, that's done uploading. All right.
So do we have to get the front first before we pop?
Hmm?
Do we have to get the front first before we pop?
No, because the size is it's too big.
Okay, got it.
So because the size is too big, we're going to take the first one out so that we have the more up to date data. I mean, this can always be changed depending on. Let's see. Stay connected. Yes. All right. Okay. So here, it's just that one had problems with its Wi-Fi. Can you see on my webcam? So we have here where I can update the Wi-Fi credentials for the duck. I'll just hold it up there for a second again. And so here I'll be able to update it. So
it will write your credentials in this serial monitor, Nick. If you click away, your credentials won't be exposed.
Oh, man. Internet, don't hack me, please. All right, so I have a little success message here. I'll just wait a second. Let's here. Open up the serial monitor again. Let's see, did it? Oh, no, it did not. Did I not do it right? Let's see. Oh. It did do it, but it did not. No SSID available. Oh, did I not?
Make sure you made no spelling or mistakes, I guess.
Yeah.
It's the pressure from the world trying to hack him. He's misspelled it.
Yeah, well, sometimes it happens that your duck isn't in range of your access point, even though it is, but it just doesn't find it. There's some.
Well, it should be trying to check. So I'll do it separately. I need another screen. Make that better.
You want to try it again?
I did try it one. I did try it one more time, but all right. So I'll have to test separately. I'll post in our Slack channel, the open source Slack channel, the results of that. But in the meantime, we can test this part here to make sure that the packet size remains 5. And I think we'll be in a good stopping point. But yeah, so
yeah, I will make sure to link all the comments and stuff.
Mm-hmm. That looks good.
Let's see if it uploads and.
Mm-hmm. Let's see, anything else I'm forgetting from here. So we initialize the queue. If the publish failed, listen to incoming packets, so we already do that. Push incoming packets into the queue. That's what we do. Set a limit. And then when we're connected, we send stored packets. So I think we accomplished everything that we wanted to do. I will just do a little bit of extra testing to make sure that the Wi-Fi stuff works. But let's see here.
Awesome.
All right, so just connected. So Q goes to 2, 3. There's 4, 5. All right, now let's see a moment of truth. Oh, it's still going up. Oh wait, no, that's actually that's right how I did it. It's not.
Interesting.
Yeah, no, that's right. It's that makes sense because I didn't do
That's
greater than or
not
equal.
good.
No, that's right. It's see now it's not increasing anymore. See, it's only 6. So I did if it's greater than 5. So if I wanted only 5 to be in there, I should have put 4. So that makes sense. But yeah, so okay, so I think we're good for today. We will be updating all the information for the stream.
Got it. So it stopped at 7?
It stopped at 6 because I set it to, where is it? Here. So it's as long as it's greater than 5. So that means that what's greater than 5 is 6. So we shouldn't have an issue. So now what it's doing is that once it breaches 6, it's going to pop the first one and then add to the end. So
that's awesome.
All right, cool. So
great.
Yeah, so I'm just going to do a little bit of extra testing, and then I'm going to put out a pull request, and we'll see from there. If you have any suggestions for what we want to do for a topic for next week's stream, feel free to comment down below or reach out to us in our Slack. We're very active in our Slack channel, so and also have a lot of amazing contributors there, so feel free to join. You can join us, our Slack, through our website. Let's see, project. There you go. Here, and then it's in the open source one. Oh no, here it's right there in the front. You can join our Slack right here. All right.
Yeah, all the links are in the comments as well. And thanks everyone for the comments and the live feedback. I think that was amazing.
Yeah, it's awesome. That's exactly what we kind of want to do here. It's a very casual live coding session where it helps people who are unfamiliar with the CDP to see how it works and how do we interact with it, but also how we can learn together how to better build the open source technology. So really excited for next week. Thank you everyone, and see you next week.